Okay, for homework 420, I'd like you to copy down these two problems and the words that I say. First word right away, poly, poly, first word right away. I want you to write down the work, the three words, and then look at this new concept I'm trying to get you ready for tomorrow. All right, for this, I want you to see that there are such things as shape transformations where we move a shape around. You need to remember all that for this problem right here for the quarter four bench. And now what are called line transformations, where we transform a line. All right, so back to this first one here. Try to draw this best you can on your graph paper. I want you to see that this first one, without the little marks, this is the pre-image. Really important. That is where it is starting. You can't forget that. The one with the marks is called the image. That means after I did the movements, that's where it ended up. So don't mix that up, or you'll think you started in red going to black. It's not the case. If I look, it looks like to me, I always, when I do problems, do a quick little reflection and see what you get. If I reflect over this x-axis right here, my triangle should look like that. It looks like not much. If I reflect, we'll get over here, won't work. If I rotate around, looks like maybe a rotation might work, but I'm not sure. But I'm thinking for this problem right here, the way I set this up to be successful, you are first reflecting across the y-axis to get here. And then you could see all these points, they rotate. And kind of to help you look at this rotation pattern, look at this square right here and know that this square is rotating to get to here. You can see that little corner rotated around. This little corner way up here, you could see this corner with the 5. It's almost like I'm taking this whole chunk and moving this to the right to get to its new location. You can see. So I can see based on that turning, that movement, it looks like it's a quarter turn to the right. If you could, try to write a coordinate to show me. This coordinate is 3, 2. If I do a quarter turn to the right, that point's going to flip, and that left one, nope, the right one is going to become opposite. Those 3, 2 becomes 2, 3, but then that left one becomes opposite. And you can see that is that point right there. I think that is, so let's see. 3, 2 became -2. Oh, I'm sorry. I switched the one on the right. Oh my goodness. Yep. Quarter turn to the right. It's that right coordinate gets opposite. So sorry about that. Messed me up a little bit. So 3, 2 switches over to this point right here, becomes 2, -3. So on your paper, I want you to write first, reflect over the y-axis, then rotate 90 degrees clockwise to the right about the origin. All right, if you could have got that by reflecting over this x-axis first, let's see if that would work really. Reflect over the x-axis first, and then a quarter turn to the left. Yep, that looks like that one would work too, because this point, quarter turn to the left, ends up here. This point ends up here. So yeah, that's another way you could have wrote it. I would have accepted both ways. You could have said first reflect over the x-axis, and then if you do that, then rotate 90 degrees to the left counterclockwise about the origin. I would have accepted that answer too, knowing that there's 2 ways to go about this one. All right, So that is math you need to remember. Here is the new stuff. We're doing line transformations now, where we take a line and we transform it, where we're taking one part of one line and we're plugging it into the other. I'm going to be hammering home in class telling you that this one all by itself, this is like the pre-image line, the line before it was transformed. This G of X is the image line, the one that's all the changes happening. And you can tell it always looks like this. The one that doesn't have 2f of x, that's the pre-image. So what this is saying is that line starts at 2x plus 3, and then what I'm doing is replacing this in here to get the new G line. Here I go. So to get the new G of x line, I replace that f of x is what it's equal to, and then I subtract that 7. Do the math right there with my 3 and 7. That will give me the new transformed y-intercept. Gives me g of x equals the same slope, but with a y-intercept of -4. And then graph them. I want you to see what's happening. +3. This line is going right 1, up 2, right 1, up 2. Be able to stair step the opposite way. That is this line right here. Second word is fish. Fish. All right, that line is the f of x line. That line is the pre-image before it was moved. The new line has a y-intercept of -4 and a slope of over 1 up 2. So you could see this new line, the g of x line, after the change has been moved down. You can see this g of x line, the new one, has been moved down this y-axis. -7 matches this number right here. That -7 going down from 3 gave me the new y-intercept of -4. That -7 is the shift. When I transform that blue equation, that 3, the original y-intercept, taking away 7, ends up down here at -4. The equations have the same slope. The first one is the pre-image one. That blue one, f of x, pre-image line, the line before it was transformed. The one in red, the image line, the one after the transformation. What was the transformation? It was moved down the y-axis 7 units. All right, so write all that. Hopefully that will give you a little head start on some of your classmates when we start looking at this. Linear transformations. Third word is whale. Whale. Good luck. See you tomorrow.